In this section, we're going to cover the introduction to relations. So a relation is simply an ordered pair, set of ordered pairs, and it's a relation between X and Y. Okay? So with this relation, you have a domain. Your domain, okay, is going to be all of your X's. That's what your domain is, your X values. And then your range is simply going to be all of your Y values. So let's just explore how this works with a finite set. So a finite set is going to be a set in which we can count the members. So for this example that we have here, our set has 4 ordered pairs. And so to look at the domain, we are simply going to look at all of our X values. To show that this is a set, we use a squiggly bracket, and then we just pull out our X's. So -3, 6, -4, and then there's another -4. See, -4 is repeated. You do not need to put -4 twice. You just list it once. There we have our domain. Now we're going to go ahead and we're going to look at our range, our Y values. So again, we take our squiggly bracket and we pull out the Y's. -3, -9, -6, and 1. There we go. For example, number 2, we're going to still do the same thing. We're going to write the relation as a set of ordered pairs. So this is what we refer to as a mapping diagram. And it will still have your X's and your Y's. So the map tells you which X maps to which Y. To set up our relation, we're going to use squiggly bracket, and then we're going to put our first ordered pair. So we see that on the X side, we have an A, which is mapping to X. That's our first ordered pair. Then we separate our ordered pairs with commas. Always separate the members with commas. Then we go to the second value in our domain, which is B. B is also mapping to X. Then we go to our next ordered pair, and we have B maps to Y. And then lastly, we have C mapping to Z. We close this relation with the squiggly bracket. So this is a relation with 4 members. Each ordered pair is a member of that relation. If we are writing the domain and the range, pause right now and write the domain and the range, and then you can see if you get the same thing as I do. So you should have gotten a domain that would consist of 3 members, A, B, and C. And then a range, which consists also of 3 members, X, Y, Z. All right. So now let's look at writing the relation we're going to look at this coordinate plane, and we're going to look at the relation as a set of ordered pairs for those 5 points that are plotted on this coordinate plane. So the first thing we're going to do is it would be easiest if we had those ordered pairs identified. So I'm just going to quickly do that. So I've got -7, -4, -5, 6, I have 2, 0, 4, 3, and 6, -3. And so if I write my relation, it's going to be squiggly bracket, and then all of those ordered pairs inside. So all ordered pairs listed. I was getting a little lazy there. You would actually go ahead and list all of them. Then we're going to find the domain and the range. So again, pause, write the domain, write the range, and then compare your answer with mine. So for the domain, you should have gotten -7, -5, 2, 4, 6, and with squiggly brackets. And then for our range, we would start with squiggly brackets, and you've got -4, -3, 0, 3, 6. So the question is, do you have to write them in order? Write each of the members in order from smallest to largest? No, you don't. The members just need to be present. But I just out of habit generally write them that way. So now let's look at, whoops, let me actually clear this. There we go. Perfect. So we're going to spend just a little bit time looking at set notation. Set notation just means, how do you describe a set it could be either finite or continuous, but we're going to be actually more interested in right now looking at in infinite members or continuous, a set that's continuous, okay? So when you have a finite set, it's really easy, okay? It's a collection of items called elements. That's called a set. And the brackets, this is what we've been doing. The squiggly brackets are used to enclose the elements of that set, okay? That's exactly what we've been doing. Well, now let's move on. And what if we can't count the members of the set because there's an infinite number of them? Well, we have 3 ways we can describe that set. So let's look at this set. It's the set of all x such that x is less than or equal to -2. Okay, so if we use what is referred to as set builder notation, that's one method for describing a set, then you would list, we still use our squiggly brackets to show that it's a set, okay? So we're going to do squiggly brackets. Then we're going to put our variable. It tells us that our variable is x. And then we're going to put a vertical line. That vertical line means such that. So far, we have the set of all x, such that x is less than or equal to -2. This right here is our description. So we're going to write that description as an inequality. So I'm going to write x is less than or equal to -2. And then we put our squiggly bracket. So let's go ahead. That's set builder notation. So now let's go ahead and let's look at another way of describing a set. And that is going to be through the method of graphing. So when you're graphing a set, you identify the endpoint, okay? Then you ask yourself, is that endpoint included or excluded from the set? So let's go ahead. We're just going to draw a number line here. Okay. And now we're going to graph our inequality. So we've got -2. And because of the equal sign, or because of the word equal, that means -2 is included in our set. And so there's two things you could do. You could just use a colored in or a solid circle to represent that -2 is included. And then because our inequality is pointing to the left, we would shade to the left and include the arrowhead. There we go. That is the set of all numbers which are less than or equal to -2. As an alternative, instead of using a solid circle, you could also use a square bracket. The other option is if that number -2 was not included, okay? So I'm going to write down here, included. You could use solid, circle, or square bracket, okay? If that point is excluded, then you would use open circle, or you could use parentheses. Okay? All right. Now let's move on and talk about interval notation. So with interval notation, you always use the format for the endpoint, to write the endpoint, small number, comma, large number. Always that pattern. If you write it large number first, small number second, that would be incorrect. It's small, comma, large. Then you use parentheses or square brackets to show whether the endpoints are included or not, just like I just explained. Included, use square brackets. Excluded, use parentheses. You always use parentheses with infinity. Okay, so let's look at an example here. So I have in set builder notation, the set of all x such that x is greater than 6. So the way we would go ahead and use that information to graph is we're going to do our endpoint, 6. 6 is not included because I don't have an equal sign, so I'm going to use parentheses, and then I'm going to shade to the right. Now, in taking that and putting it in interval notation, my smallest number in my set is 6. My largest number is infinity. Because 6 is not included, I use parentheses. Infinity always uses parentheses. Okay, let's look at this next example. So the way I've got this graph in the middle that shows everything shaded less than 7. So to write this in set builder notation, the set of all x such that x is less than 7, squiggly brackets. In interval notation, this is going to be -infinity, comma, 7, parentheses. Parentheses are on both ends because with infinity, always parentheses. The 7, because we have a parenthesis here, that's why we have a parenthesis in interval notation. It shows that 7 is not part of the set. Let's look at this next example. So -7/8 to infinity. Let's start by graphing -7/8. Because there is a square bracket on the interval, that means -7/8 is included. So I'm going to put a square bracket on my number line. because it's showing that it goes all the way to positive infinity. That is my largest number. Positive infinity is way over to the right. So I'm going to shade in like that. There we go. Now let's put this in set builder notation. Set of all x such that I've got x is greater than or equal to negative 7/8 and my squiggly bracket. Okay, for this next one, I would call this what I refer to as a betweener. So what I mean by that is our set is going to be between 3 and 7. And betweeners always are the format where you have two less than signs and you have your variable in the middle. You have your smallest number on the left and you have your largest number on the right. That is the format all the time. So this makes it really easy to graph. We know that we're between 3 and 7. I look at the inequalities. There are no equal signs. So that means I'm going to use parentheses, and the 3 and the 7 are not included in my set, but everything in between is. There we go. Now to pick this up and put it in interval notation, not hard. My smallest number is 3. My largest number is 7. Neither of those are included, so I use parentheses on both ends. Pause the recording, and go ahead, try this next two examples, and then click play, see if you got them right. So I'm going to put them, graph them. I'm going to go from negative 3.1 to positive 3.1. Because I've got square brackets, I'm going to use square brackets on my graph, and everything in between are shaded. So when I'm putting this in set builder notation, it's squiggly brackets, the set of all x such that. Those two endpoints are the endpoints on my inequality. And I'm going to use two less than signs with my x in the middle. Because I have square brackets, that is telling me that my endpoints are included in the set. So the way I show that in my inequality is by putting a line showing equals. Now for the next one, it's going to be squiggly brackets, the set of all x such that. This, just because we have a symbol pi, pi represents a rational number, okay? I'm going to keep pi in my inequality. So it's going to be the set of all x that is less than or equal to pi. Remember, pi is just 3.14, okay? All right. Let's look at putting this in interval notation. So my smallest number is negative infinity in this set. So it'll be, oops, that looks like an 8. I don't mean it to be an 8. It is going to be negative infinity, comma, pi. Negative infinity always has parentheses. Pi, in this case, that endpoint is included, so it would be square brackets. All right. So you should have a better understanding of how to use set builder notation, graphing, and interval notation. They all do the same thing. They all describe a set. We use it, any three of these methods, when we're describing a set that is infinite or continuous. Okay, so we can have a set like this one. Let me just move this up a minute. Get this out of the way. There we go. So let's look at this set. So I've got a circle here on this coordinate plane, okay? So I want to find the domain and the range. So my domain, when I express it using interval notation, is going to be my x values. So my x value that is furthest to the left is going to be -5. That'll be my smallest number. My largest number is going to be +5. My circle goes through that point. And so I'm going to use square brackets because it goes through both of those endpoints. Now, when I find my range, okay, I look at my y values. So up and down. So that's going to be from, again, -5 to +5. That's just coincidental. Okay. So I'm going smallest -5, largest number on the y-axis, +5. Again, square brackets. Okay, let's look at this next example. We're going to use interval notation to express the domain and the range of this parabola. So this one is a little bit interesting to find our x values. Remember that our coordinate plane is set up in quadrant 1, okay? My x value is positive and my y value is positive. In quadrant 2, my x value is negative, my y is positive. In 3, I've got negative, both my x's and y's. For every ordered pair in that quadrant 3 is negative. In quadrant 4, for each ordered pair, my x's are positive, my y's are negative. It was important for us to take just a moment to look at that because this parabola is going infinitely into quadrant 3 and quadrant 4. So when I look at quadrant 3, my x value is negative. And because it's going infinitely down, my smallest value is going to be a -infinity. For quadrant 4, okay, then my x values are going to be positive. So to write my domain, okay, I'm going from -infinity to +infinity. Now, to write my range, that's my y values. So my y values for this particular parabola, the smallest number that I'm going to have on my y-axis, okay, we're both going down. So my y's are both negative as I go down in quadrants 3 and 4. So my range is going to be, it's going to start at -infinity. But then as I work up, okay, the highest point is going to be right there at 9. So we go from -infinity to 9. And it goes, my parabola goes through that 9. And so I use a square bracket. That was a little interesting, but I think you got it. All right, we're going to end here.